so great.
Okay, synthetic division. Okay, you can feel free to read through the steps at your leisure. I'm not going to read through them. I'm going to kind of just skip to the practice at the back, and I'm going to walk you through sort of the gist here. So feel free to go back and read these steps if you need a refresher later, or if you're lost or whatever. Okay, so take a look. Imagine we don't know the answers, okay? We want to divide this polynomial by this one here. Okay, now, is everybody listening? So you can do long division if you want. You absolutely could. But there is a much faster way that we want to get familiar with, because we're going to be using synthetic division quite a bit for the rest of the chapter. Okay, so let me just refresh your memory if you have forgotten. So it's a way to do the same division, but a lot faster. So what we're going to start off with is I'm still going to check that there's no missing degrees, just like I would if it was long division. So I have to the third, second, first, none. So I have all my degrees represented right there. So the first thing that I'm going to do is I am going to write down just the coefficients. So 4, -10, -11, and 16. Yes. Go so fast, you're going to miss this. Ah! Now, everybody sets up their synthetic division a little bit differently. I don't know. I do kind of a long L shape. So I leave some space underneath those numbers. So I draw something like this. I mean, if you have some other convention that you use, it doesn't matter. You do whatever you want. And now here's what's important. Whatever you're going to divide by here, okay? They want me to divide by the binomial x minus 4. You are going to synthetically divide in the 0 that would come from that factor. Okay, so if I were solving a quadratic, right, and I got a factor of x minus 4, isn't positive 4 the 0 that comes from that? So that's kind of important to remember, because sometimes they'll just say, you know, hey, one of my zeros is 4, or they might say a factor is x minus 4. All right, so either way, well, this one isn't actually a factor because I have a remainder. But anyway, if they give me a binomial, I just want to plug in the 0 that would come from that. So in this case, it's a positive 4. Okay, so if they said, hey, synthetically divide by 7, I would just plug in 7. If they say, hey, I want you to divide by x plus 7, then I'm going to plug in -7, right? Because I would want the 0 that would come out of that binomial. A little confusing, but once you get the hang of it, I think it'll, or if you remember all this, even better. Okay, now to do the actual synthetic division, do you guys remember what to do?
No. Yes.
Not a clue?
You bring down the first one.
Yes, the first number just drops down, whatever it is. And then you multiply your number out here by the number down here. So in this case, that would be a 16, and you write it right in this spot. And then you add these two together. So that would leave me with a positive 6. And then I basically keep this process going. I'm going to do 4 times 6 now, which of course is 24. So I would just write that over here. Add these two together. I'm left with a 13. And then I do it one more time. 4 times 13 is 52? 52. 52 and 16 is 68. Okay. Right? Or did I mess up? No, I'm right. Let me explain what these new numbers are. These are the coefficients of your quotient, but it always goes in this pattern. The very last number is your constant. Oh, I'm sorry, it's your remainder. Forget I said that. Last number is your remainder. Sorry.
I didn't know race.
So this particular one has a remainder of 68. Okay, cool. The next number is your constant. And then this is my linear coefficient, or whatever comes in front of the x, right? And then I just go up by degrees. This would be x, this would be x squared. If I had more, I would just keep going up. So its official term is linear coefficient, linear term coefficient. What goes in front of x. And then this would be my quadratic term coefficient, and so on and so on and so on. But it's really just, oops. What goes in front of the x squared. So to sort of rewrite this answer as like a normal answer, because that's just a bunch of numbers, right? So this turns into 4x squared. They're all positive, so I'm going to have a plus 6x plus a 13. And then my remainder, remember how we handled that? Put the remainder over what you were originally dividing by in your original problem, which was x minus 4. Oh, for Pete's sake. There we go. So if you had done long division with the exact same problem, you would have gotten the exact same answer. Hopefully. This, hopefully, oh, I'm saying hopefully a lot today. So you will notice that the synthetic is much, much, much faster once you kind of get the, you just got to remember how to do it, and then you'll be like super fast. Okay, so let's just try number 2. So same idea, I'm going to sort of squeeze it in over here. I'm going to start off with all of my coefficients. And what is it I'm going to plug into this? What? Oh. Yes, you are correct. I am missing a degree. So see, I have 3 and then I'm missing the 2. So I need a 0, -2, and then a 1. And then what's the value I'm going to synthetically divide in? If I want to divide by x plus 1, I plug in a -1. Because I always want the 0 that would have come from that factor. And now go ahead and just do what you do. So one more time, if you forgot, you're going to drop down that first number, whatever it is, it just drops down. And then I do my multiplication. -1 times 1 is a -1. I'm going to add these numbers together. Keep that multiplication going. Now, see if you can turn these digits into the answer, right? You need to know what those numbers do. So I always start from right and I move my way to the left. So the last number, remember, is always going to be your remainder. The next number is always going to be your constant. That's the coefficient of x. That's the coefficient of x squared. If you had more digits, you would just keep going up, right? So you'd have x to the 3rd, x to the 4th, and so on and so on and so on until you run out of numbers. But you got to make sure that you start on the end the right way. Remainder, constant, and then it's coefficients all the way up. Did someone tell me what this turns into then? This becomes, Cedric, go ahead.
X squared minus x plus 1. You add in the remainder?
No, they're separate. -1, and then you're going to have a 2 over whatever you were dividing by, which was x plus 1. So that whole thing is your answer. Thoughts? Okay, let's jump to one that's a little bit tougher. How about I mean, I know you have the answers right in front of you, but pretend you don't. Jump to number 8. Let's all try number 8. When you have completed your synthetic division, see if your coefficients match mine. And then go ahead and turn that into an answer, right? Because right now it's just a bunch of numbers. You need to now transition that into your answer. Make sure you have your 0 placeholders, including for the constant, right? I need everybody represented. So every degree, which would include x to the 0 power, which is just that constant. Okay, so if you stop at 10, if your last number here is a 10, you just need that extra 1 for the constant. So I usually just say it out loud in my head. So I go 4, 3, 2, 1, none. Everybody's got to be there. Okay, so who can tell me what this is as an answer? Go ahead, Grace.
Oh, x squared plus 2x.
Whoa, 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 whoa.
Wait. Oh, wait, x cubed plus 2x squared plus 5x plus 10 plus 2, 20.
Yeah, that sounds good. And there it is. Ta-da. One more real quick before we do something else with these. Can we try go for number 6? This is number 6, right? Now, what does this mean if I get a 0 over here? There is no remainder, which they could have said, they could ask this same question another way. They could say, hey, is x minus 1 a factor of x cubed minus 1? If I end up with 0 as a remainder, then yeah, it is a factor because it went in evenly, right? So if you are ever asked, is blah, blah, blah a factor of blah, 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 you can just do synthetic division, see what comes out. If your remainder is a 0, then yeah, it's a factor because it went in evenly, right? Does that make sense? Okay, cool. So turning this back into an answer, remember that's my remainder, that's my constant. So there's x squared. So write it nice and neat, x squared plus x plus 1. And then I don't have a remainder, so I don't have to worry about that part. Thoughts, questions, concerns, worries, fears, none? You feel good?
What?
Yeah, I feel that. Okay, there's something really, really, really cool that you can do with synthetic division. Did you know that you could evaluate a function at a given value using synthetic substitution? Did you know? So for example, let's say I asked you to do, I'm just gonna make up some function. Let's say it's like 5x to the third minus 6x squared plus 2x minus 5 when x equals -2. Let's say that you were supposed to do that. You could simply take -2 and plug it in for x and do the math out. But do you remember that remainder theorem? Do you recall? Anybody? You can just do synthetic division, plug in -2, and whatever the remainder is the answer. So without having to like manually do all that work out, you certainly could, but my gosh, once I'm good at synthetic, I can watch how fast we can do it, right? Just drop down all your coefficients. 3, 2, 1, none. When you're doing this, you're going to drop in exactly what's there, right? This isn't a factor. This isn't a binomial here. They want to know, hey, when x is -2, so let's pop in a -2, and whatever my remainder is the answer. That's it. The answer is just -73. The value of the function when x is -2. So f of x, so in other words, f of -2 is -73. That's so cool. You with me?
Yes.
Miss Sabia, does this get harder? Sure. Oh, it does, because we can throw in some imaginary numbers.
Oh.
Ow. You guys.
It's a whole lot easier if I just pay attention to math stuff.
I would agree with that.
That's
Good thing you're here now. Ain't that? All right, so let me see. What do I want you to do? Let's do. Oh, gosh. Oh, wait, you know what? We're gonna do, never mind. We're gonna get into that more tomorrow.
Good.
I don't think, yeah, today I don't think we will so much.
Wait, I mean, yeah.
All right, so let me give you. Try to decide which one I want to do first. I have both of these. Oh my God, with this thing, right? Oh, so frustrating. Let's do this one first. I also want to talk to you about 1 through 6. We'll see if you remember what to do with those. There you are.
We're gonna go for a walk today.
At 2:02, you're gonna walk yourself right up the building.
You're welcome.
Yep.
Okay, everybody. So if you take a look at like 1 through 6 here, they want you to divide these, but you're only dividing by a monomial. Do you remember how to do that? It's easier than you think. If I have a polynomial here and I want to divide it by this monomial, anybody remember? Almost. So basically what you can do is you're just going to divide each term by whatever you're dividing by. So everybody's going to get divided by 4r squared. And then I literally just divide it into each one. So this would just be 2r to the third, right? Plus 2r squared plus 3/4 doesn't divide nicely, so it just stays 3/4 r. Do you guys see what I did there? That's it. So if you're dividing by a monomial, you just divide every single term by whatever that monomial is. That's your answer. That's it. So try number 2.
Wait, I don't get it.
Oh, so yeah, let's do that one together actually. So when I divide the first ones, I just get a 1, right? Now 3 divided by 10 doesn't reduce, so I just leave it as 3/10. And look what I have. So you could either leave, what are you gonna have left with the x's? Yeah, so you could either write it as x to the -1, or you could just have it as an x in your denominator. Right? And then the last one, 40 divided by 10 is a 4. And then I'd have x squared in the denominator. So I should put 4 up top. Are you guys with me or not so much? Okay, try 3 because 3 works out really nicely, I think. Yeah? Did you get what I got for number 3? So again, that is when you are dividing a polynomial by a monomial. You can just divide each term by that. Okay, so let's jump down to number 7 then. This is what we were just talking about. So I want to know the value of this function at 4. Sure, you can plug in 4 directly and do out all that math if you really want to, but you have a better way now. What should you do that's way faster? Yes. And my answer is just going to be the remainder. Whatever the remainder is my answer. 3, 2, 1, none. Okay, not missing any degrees. And what do I plug in? When it's written like this, what am I actually plugging in over here? Yeah, I really plug in 4. The only time I do the opposite is when they give me a factor, like x minus 3. But they didn't give that here. They just gave me, hey, what's the value at 4? So I plug in 4. And now I just do my stuff. Your remainder is the answer. Isn't that nice? So much better than literally, plugging it in directly. Totally possible, but annoying. Try number 8 real quick. And what's my answer? It's just 8. Sometimes kids get confused, and when they ask a question like this, they give like they turn all of these into the coefficients and give that whole thing. I'm not doing division here. I'm evaluating the function at a given number. So my answer is just gonna be a number. It's literally just saying, hey, what is the value of this function when x is 4? Right? If I ask you that in normal language, you don't answer with a whole long polynomial, right? You just give me a number. So flip it over, if you would. Now let's take a look at like 15 to 24. Someone pick a number in there. 16, I heard. Okay. So here, I literally want to divide these two. You have 2 ways to do this right now. You could do long division. You could do synthetic. By the way, I don't think I clarified this before. You can always do long division, but you can't always do synthetic. Does anybody remember when you can't do synthetic division? Yeah.
With the, or all of that.
You can do it with imaginary. It's just a pain. But it is, we'll do it tomorrow probably. But there is something about your divisor that has to be true. Anybody remember? Your divisor basically has to be 2 things. It has to be a binomial. So if I wanted to divide this polynomial by like b squared plus 2b minus 4, I can't do synthetic with that. I'd have to do long division. And I also want the leading coefficient of my divisor to be 1. If it's not, you can kind of get away with it if you plug in the fraction, like if it was 2b plus 3. You can kind of plug in a -3/2, but if you're not doing yourself any favors, just go long division. Okay, so really you need this right here. Is everybody listening? Because this is important. That thing right there has to be some variable plus minus some number. If it's anything else, if I have a leading coefficient here that's something other than 1, I really don't want to do synthetic with that. If it's not a binomial, I'm not doing synthetic with it. You can't. So that's important to remember. So long division, sure, you can do it anytime you want. Synthetic, we love it because it's so much faster, but you can only do it when you are dividing by a simple binomial where that leading coefficient is not 1. You follow?
Yes.
Okay. So we're trying 16, right? What is it you actually plug in? If that's what I'm dividing by, right here, I should plug in -3. I hope you did a negative. And what's my answer this time? What am I doing with these things? Is my answer just -8? No, that's the value of the function at -3, but that's not what they're asking. They want me to divide this whole polynomial by this whole polynomial. So this, I do need to turn this, these are all coefficients. I need to give what that answer is. So remember how it works. The last number is your remainder. This number is the constant. And then you start with the x's. So that's x to the first, x squared, x to the third. So when you write it all nice and neat, it's going to look like the following. You ready? X to the third plus 2x squared plus 10x minus 2, and then my remainder. Since it's negative, you can write it as -8 over whatever you were dividing by, b plus 3. Oh, I put x's instead of b's. Whatever, I'm switching to x, sorry. I always do that. Should be more careful. Thoughts, comments, questions? Pick another number 15 to 24. Shout it out.
22.
22, okay. 22. Everybody try it. We'll see if we all match. Did you get what I got so far? But now you got to turn that into an answer. That's not an answer. That's just a bunch of numbers. Who's got it as an answer? Go ahead, Jake.
1x cubed minus 3x squared plus 6x minus 3 plus 6 over n plus 10.
Looks good to me. No. Yeah, because you have a binomial down here, so you can't do like a piece with a, you can't simplify a piece of the binomial with something else. Yeah. It'd be all or nothing. Oh, they were supposed to be ends too, whatever. I never, so I'm gonna switch this one to an X. How do we feel? Okay. Does anybody have any questions? Are you sure? Oh, I mean, okay, if you say so. All right, so I think I will give you, I have your homework here, which isn't too bad. Yeah, let's do this. Okay, so your homework is going to be a mix of long division and synthetic. So there's a section where you have to use long division, and then there's a section where you have to do synthetic, and then
You get to choose.
then you get to choose. What fun. Okay. So let me give you this, and then that'll be it. If you are looking for more practice, there's a whole bunch of problems on that sheet that we were just working on that we didn't do. You're more than welcome to try it. This is the homework that I'm handing you right now. 4, 5. 2, 3. Oh my God. Sorry. Okay, let me stop this.